Welcome to the Optica Online Industry Meeting on Robotics. It is great to have all of you here. Today is a very important meeting because we're only 4 to 5 days away from Automatica, and we are all going to meet in Munich next to Laser World of Photonics. Today we wanted to do something very special. Today we wanted to present a use case. We want to see how companies who can do very smart beam steering, companies who can do very affordable long-range LiDAR, and companies which can provide other solutions can help a robotics company, Optica corporate members such as Demcon. So for that, we have put a use case on the table. We have Demcon as the integrator and 3 enablers, SteerLight, Flatlight, and Scantinel. Over the next 1 hour, we're going to try to make sure that all of you find business. This meeting is not just for the companies mentioned here in this slide. It's for every one of you, everyone in the room. You are welcome to voice your opinion, whether you're a robotics company or a photonics company enabling better robots or better artificial intelligence for robotics. It is the time to voice your opinion and to show your technology. This meeting is part of our series of online industry meetings. We are halfway through. Next 26th of August, after the summer break, we come back with the medical imaging. If you want to show your technology at any of our upcoming industry meetings, we have everything announced all the way to the 10th of February. Select the ones that are useful for your technology and contact us. Corporate members can always show one slide that sponsor one event or this particular list of online industry meetings. And also, I would like to remind everyone who is a corporate member that you have access to our network, to our market reports, to all our year-round events everywhere in the world, and of course, the promotion and engagement opportunities. And if you are involved in the optics industry, your account manager is Olga Raz. Olga Raz was in charge of putting the agenda together today. And she made sure that you have robotics companies and photonics companies who can interact. She identified business opportunities for all of you because that is her job. Before we start giving her the floor, allow me to say something for the YouTubers of the world. This meeting is live stream also in YouTube. If you have any questions during the live stream, you can put them in the chat and I will read them in the room. And of course, you can watch this at this time or at any other time that is more convenient for you. And with that said, Dr. Olga Raz, Director of Optics at Optica, please let us know what's about to happen.
Thank you, Jose, and welcome everyone. We're a few days away from the Automatica, we're a few days away from the Laser World of Photonics, and both these large conferences brings actually massive, important technologies together, photonics and automation and robotics. So here it's for us a briefing and a preview on how these two major technologies or two major fields can actually work together, photonics and robotics. And so without the further ado, I would like to introduce the opening keynote, Jeroen Minnema from Demcon. Jeroen is a lead systems engineer and a very enthusiastic robotics engineer with experience starting from everything. Solar cars development and autopilots for Embraer. Jeroen, the attention of everyone is yours. You're very welcome. We're looking forward to your insights on latest trends and challenges in robotics.
Thank you very much. Hopefully everyone can see my screen, I guess. Yeah.
Perfectly.
Stop. Perfect. So thank you for the opportunity to speak here. My name is Jeroen Minnema. I work as a lead systems engineer at Demcon, and today I'm going to introduce you to what we do. So as it's a relatively short meeting, I presented a few topics to you, basically on what we do in the field of robotics. Although first I will briefly introduce Demcon, because Demcon is a company that works in a large variety of markets as a developer and manufacturer of high-end systems and products. But then specifically, I will quickly put the focus on what we do with robotics, and I will focus on a very interesting case study, which is the development of a pipe inspection robot. So first, very quickly, Demcon. Demcon is, like I said, a developer and manufacturer of high-end systems and products. We started more or less 30 years ago, slightly longer. Our core competence is mechatronic system design. So indeed, definitely a systems integrator. And yeah, we work in quite a range of markets actually, ranging from aerospace, water and maritime, defense and security, for which I've been working a lot myself for the past couple of years, but also in the fields of energy, smart industry, life science and health, and more. We have about 1,100 employees, are based in the Netherlands, in the city of Enschede, where I also live myself. But we are actually based in a total of 4 countries and have 9 locations. Yeah, now robotics at Demcon. Demcon is definitely a developer and also integrator of robotics. So all the robots you see on the right, whether it being naval unmanned surface vessels, UAVs, or UGVs, unmanned ground vehicles, these have all been developed or made autonomous and unmanned by Demcon. So a wide range of applications. What's especially interesting is that all these systems, in order to be really useful and meaningful, is not only the hardware design, that's not enough. It's really that they have to behave autonomously. That's the real key benefit and also the scalability of these kinds of systems. Without being able to do actions autonomously, the value is in that sense limited. And that brings along quite a few challenges, especially in the fields of optics and also related to lasers. So mainly a robot has to know where it is and what its environment looks like. And because of that, and because Demcon works in such a range of applications and has developed robots in a wide variety of applications, it doesn't matter if the robot is in the air or on the water, or under the water for that matter, or in pipes. It has to know where it is and what its environment looks like. And therefore, we built a system, basically our own system, that's relatively platform independent for sensor fusion and perception of the robot, that can provide the input for unmanned control, whether it being a flight control or a route planner for a waypoint selector for unmanned vehicles. That does not really matter, but the key challenge is robust GPS-denied localization. Another example is the step that comes beyond that. As soon as you have a map and a location, is path planning. How are you going to do that? And how do you translate the robot's understanding of its environment into an actionable actions that it can take? And related to that, which is really something we've been focusing on the past couple of years, are the application of AI for semantic understanding, but that brings along the problem that you need realistic data for them. And therefore, Demcon, another subsidiary company from Demcon called Demcon Data Driven Solutions, has developed a synthetic data pipeline that we can use to generate training data. As you see here, the picture you see here, it almost looks like a photo, but it provides a segmented ground truth for the segmentation and development of AI networks that can really tell the robot where it should drive and where it shouldn't drive. So you're not only relying on depth information, for example, by a LiDAR for obstacle avoidance, but also can use and add the added benefit of a vision-based system that can really tell you something about the environment and specific properties of them. And then into my case study, which is about pipeline inspection. Already a project Demcon has been working on for quite a few years, and that's because in the Netherlands there's more than 120,000 kilometers of pressurized water pipelines that are usually on average about 5 to 6 decades old, and new construction is very difficult and expensive, and the quality and status is quite unknown. Repairs and replacements are poorly documented over time, and therefore there are some networks under the ground, but the current status is difficult, and inspecting is very difficult, and reactive maintenance is no longer an option. So the solution is uncrewed autonomous inspection, and therefore Demcon was requested by a range of drinking water companies to develop an autonomous solution for them. And that's what we've done. And that robot is quite a complicated system that ranges from a large variety. The robot, for instance, you see a prototype model here. It has to navigate through quite narrow pipes of down to 65 millimeters actually. So it's almost a snake-like robot that's subtracting it, completely designed from the scratch. It has to do autonomous navigations in a GPS-denied semi-structured environment. But it also has to enter and insert in a pipe and have to get out of it somewhere else, which can be quite far remotely. has to sometimes has to do transfer data and also energy to the system, so wireless charging, and first and foremost, it also has to do inspection measurements actually in order to be useful. And just a few aspects that make this so challenging. First of all, the robot has to be able to detect junctions, but in the development process, it was really difficult to gather realistic data without having a robot that can do that. So you can probe to a certain extent, but not far enough. So what Demcon did was we set up a synthetic data pipeline that can generate render images, and that really look very much like the actual camera and the render. And we can use that to train a synthetic an AI model to be able to detect those junctions. And once you can detect them, you can actually also do the autonomous navigation. And it also includes recovery behavior and other kind of difficult, complex situations. So that's just a very short example of what we've been doing over the past years. And the application on the ground, in the air, or under or on the water, it's all very interesting, and we really like a challenge. So that was my story. And if you have more questions, please reach out to me. You can contact me via my email address. Thank you very much.
Thank you so much, Jeroen. So if we're looking at the developed robot, what were the photonics technologies that you incorporated? You have a camera, but then other sensing solutions or sensors also for tactile feeling of the surrounding environments. What went into game to make this robot work and make it smart?
Yeah, a lot actually. And to focus a little bit on the photonics and also the laser side, for instance, the actual measurement of where the junctions are, that's a really difficult thing because the robot has to anticipate its behavior. Sometimes it has to already steer to make a corner well in advance. So we built a laser-based system that could really detect those junctions ahead of the robot. That was difficult. And there's also a lot into the system in order to be able to do the measurements indeed in the tactile area as well. But it's different kind of applications. That's indeed something. And there's of course a lot of software and really a lot of also recovery behavior because people controlling it. The robot has to be able to measure its status itself because the operator cannot access and can very limitedly or most of the time not communicate with the robot. So that's really where the challenges are. So it needs all the sensors that are required to also get it out of tricky situations. If it gets stuck, it has to get out of it itself. We can't dig it out. That's very expensive.
Okay, so you leave it there. And
no,
if we're
get out, yeah.
And if we're speaking about, the camera, because as much as I understood now, so the robot mainly orientates its via vision. So what are the critical parameters for the camera for it to be able to support the functionality?
Yeah, I must admit, I wasn't into the main design of the camera system myself at that point. I was mainly in making the system behave autonomously. But the critical parts of the camera are difficult lighting conditions, of course. So it was a customly designed camera by Demcon Focal, which is our vision engineering department actually, of which I'm not a part. So, but indeed, the difficult lighting was a situation, but also the field of view and the distance at which it had to see obstacles. Of course, it all had to be a waterproof because the system is pressurized. So we had to develop something that could operate under quite high pressures. So yeah, those kind of challenges were all part of the camera development.
What are the critical dimensions of the robot? Like simply, how big is it?
It's pretty long, a couple meters basically. But one of the key challenges is that it has to be able to navigate it both in varying dimensions of pipes, ranging from the smallest part is actually about 65 millimeters. So it really has to subtract all its wheels to go through. And also up to, if I recall correctly, 130 millimeters. So that's indeed quite a range. So it really has to stuck itself in. That's the concept. Basically, it can retract the wheels, and then it can use those to propel itself as well, and even in the pressurized underwater, basically.
Thank you so much. Are there any comments possibly from the audience, Jose?
Yes, first of all, I'm a huge fan of Demcon. You know this. We have, Jeroen, a lot of friends in common in the company. I'm a huge fan of your inspection, quality control, but also all the activities that you do in handling and pick and place. So today we have a lot of people in the room who are at this meeting because Demcon is here. And one of those you're going to be really excited about. The first time I met this company, I got goosebumps. Mark from InnoSize, do you have something that could be interesting for a company active in automation of handling and pick and place?
Yeah, of course, of course. For us, it's something which is really interesting to see and to discuss. So I can quickly show you just what we are doing. So we are building. At the end of the day, it's the fingertip of the robot. So we are building this kind of gripping devices based on nature. I hope you can see. You might see my screen a little bit just to get a picture of it. So we are doing out of nature gripping systems which you can put in front of a robot, but you could put as well. It's a fingertip on a humanoid robot or a drone or something else, and to grip and stick objects. And at the end of the day, it could look like this. What we can bring to the table is that we see that we might handle like this kind of small lenses or glass fibers or even small chips. And that's something what we are doing. And I think this is really important to bring it to the table and to add this to the robotic ecosystem.
Jeroen, is there any particular need that you would have for a gripper that could actually pick and place anything from grams to hundreds of kilograms and that would not even damage it because you are not applying any force to it? Could you think about a use case at Demcon?
Technology, actually, yeah. In my short presentation, I've mainly been focusing, as you could have seen, on the mobile robotic applications, but Demcon does way more than that. We are also really we have quite a large department in the high-tech system field and industrial systems, and they really also use pick and place manipulators, and also they need grippers a lot as well. So yeah, it could definitely be something interesting to integrate indeed as well. Yeah, really exciting.
David
Thank you.
Cheskis, are you with us today? Olga, I think I just lost David, but I wanted to tell us about the shortwave infrared cameras that they are using in the robotics market. David, I will come back to you. Back to you, Olga.
Thank you so much, Jose. I'm please, if for questions, use the our chat or our Q&A, and then we will bring the questions up. At the moment, that let's switch and invite to the floor our next speaker, because we already had a very interesting discussion before with Jeroen about cameras versus LiDARs. Jeroen, your comment. You know, because I remember, I mean, everyone was, every LiDAR developer was triggered by the Elon Musk saying that LiDARs are not needed and that the cameras are the way for the autonomous future. However, it doesn't seem to be the case. And in your applications that you see in robotics, cameras versus LiDARs, or is it, are these the synergy of the technologies?
Yeah, in most robots that you saw in the presentation, very early glimpsed on, but that we've been developing at Demcon, we use a combination, and we really use the benefits of both. So as I told you about the techniques that we use for semantic segmentation, for advanced off-road navigation, we use the camera, the benefits of cameras, of course, but in order to look further ahead, and we also use the long-range systems based on LiDAR. So we really use a combination. You have to look far. If you also, especially if you want to drive faster, you also need depth information that's pretty far ahead, and that's one of the limitations of optical systems. On the other, so it's really, I would argue, it's a combination of both. And then in some applications, also in the defense and security applications, you also want vision systems. Of course, the LiDAR has a limitation on visibility at night. That can be in the military domain, that can be a challenge. But in civil applications, I would really argue there's always a case for both. LiDARs have the advantage of long range, accurate vision, and cameras have high resolution, and both can really benefit from semantic segmentation, also in the LiDAR domain. That would be my comment.
Thank you, Jeroen. And I see that Stanislav is already smiling when you mentioned high resolution, because I believe he will present us his cloud point, point cloud simulations. And in this, with this introduction, I would like to invite the next speaker to the floor, Stanislav Aksarin from Scantinel Photonics, who really that developed LiDARs that see really far. Stanislav, the floor is yours. Well, all right, then Stanislav, please figure it out.
Well, we saw
Please.
Stanislav, there is something that Henrik Madsen, CEO of SPIO Systems, put in the chat, which I think is very interesting from Jeroen from Demcon. Jeroen, come back, don't leave, stay with us. It's going to be a short meeting. Henrik, you just put that you can achieve short distance vision. Could you tell us more about this?
Can you hear me? We can see a need for very short distance 3D or vision system for small sized robotic application. For long distance, there's certainly a good amount of solution for time of flight system, but when you go below 10 millimeter and even 5 millimeter, the time of flight is really challenging. So we have a good idea to make an optical design for that short distance, but not least also the touch sensing or the pressure sensing or for grippers, because if you need to grip an item, you have one point touch sensor or grip, then you have not the resolution to grip right. So there's some case on making a really high dense pressure sensor for gripping application based on optical design.
Sounds very interesting. Yeah, like I said, in the field of mobile robotics that do unmanned navigation, basically you're typically looking further ahead. But I think also definitely when you're combining it with a gripper, really, and that's also something we do at Demcon, even though I did not focus on it, like I said. But then definitely the short range, measurements, accurate measurements, and also pressure sensors are, I would say, essential for proper control as well. Also, the more low level control that could greatly benefit or even require, close touch pressure sensing.
Okay, interesting. Maybe you should get in contact afterwards.
Thanks, definitely.
Okay.
Oh, can you hear me now?
Yes, we hear you now.
Okay, thank you.
Perfect.
Sorry for this technical issue.
To the long distance vision LiDARs.
Yeah, I can have actually both, and let me present. So thank you, first of all, for this invitation. I think it's very interesting format of the sharing the knowledge, sharing the ideas and the technologies, and to grow the community and discussions through the discussions. So do you see my screen now?
Yes.
Okay, so then I am Senior Manager Systems Engineering at Scantinel Photonics. I'm representing the system engineering team. We are system engineers, and we are building the architecture of the photonics LiDAR. So Scantinel Photonics, actually, the company who is focused on the development of the technology for the LiDAR applications in the automotive market. We also we are open for the robotics market and autonomous driving. We are developing the FMCW LiDAR, and our current focus is on the bringing the complexity of FMCW LiDAR through the photonics integration to the customer. So Scantinel is founded 6 years ago in Ulm, Germany. We have 60 plus employees. We are spin-off startup from Zeiss, Baked by Zeiss and Photon Ventures. We have some automotive and industrial partners at this moment. And let's go through the robotics case. So I really was interested that you have started this discussion exactly from this point that I wanted to start as well. So the camera-based sensing and perception solutions in mobile robotics are always simpler and reflects the principle of human vision. We can mimic our human eyes. We can also perceive the surroundings much better and simpler with the camera vision. It's always affordable and lightweight. And then the question why we actually need LiDARs. LiDARs-based solutions, unfortunately called usually more expensive and have low frame rate, not comparable with high-speed cameras, always bulky and vibration sensitive, pressure may be sensitive as well, power consumption hungry and requires complex supply chain and fabrication, and remaining less attractive until we will specify our goal. And what is important to say that LiDAR is needed in all the cases when we have to look into the reliable detection. So we are not confused by some features or the errors in or some specific object shape in the camera that appeared. We are able to operate in real conditions and all scenarios like adverse conditions, weather conditions, provide detailed information about surroundings with high precision. And LiDARs are actually an enabler for precise scanning for mobile and stationary applications in the warehouse logistics, industrial automotive, industrial automation and metrology, delivery services, security, and military. Let me explain why we think that FMCW LiDAR is actually interesting. Not a time-of-flight, because we are not building time-of-flight, we are building FMCW LiDAR. And together with FMCW LiDAR, we can bring new challenges, we can solve new challenges and to deliver much interesting solutions that will solve exactly your problem. And first of all, it's excellent radial, spatial, and temporal precision. So the LiDAR, FMCW LiDAR, can be configured, can be designed to measure precisely from millimeters down to submicron precision. When it's needed, we can do this reconfiguration of the LiDAR and deliver the high precision because we are operating not in the time domain, we are operating in the frequency time domain. It's totally different approach compared to the time-of-flight LiDARs. And then another point is the high resolution, angular resolution. So the beam steering, solid state steering, and the high pixel rate can enable the high precision in the angular resolution and high resolution, high precision, so both actually. And this is a very important pillars when we can say that when we have to be precise, we need to look into the FMCW LiDAR. Then the ranges. Thank you, Olga, for picking up this ultra long ranges. It's very common that FMCW LiDAR can be scaled up to a few kilometers, even more kilometers. So there is examples of 10 kilometers measurements, precise measurements, actually. And sometimes in robotics, we don't need this. And Jeroen showed this, that sometimes 20, 30 centimeters is required. And this is a range that we also can scale down and have this maximum range measurement of the millimeter with a submicron precision. So this is achieved by the indirect measurements of the range through the frequency, as I already mentioned before. Doppler velocity per pixel. This is a key feature of FMCW. When you're moving and scanning something, you always experiencing changes in the surroundings, changes of locations, and some objects are moving towards or outwards you. The important here, the goal is to enable high precision localization and mapping of your position, then enable object detection and prediction. So this is a Doppler velocity, like a big pillar, enabler of such applications. And maybe we can also talk about this with Jeroen. But when you have very degenerated environment, like a pipe, there is no features inside. It's very uniform. And the LiDAR or the camera cannot pick up their location because there is nothing to be changed and nothing that you can pick up as a refer and understand your position through this pipe. I hope this will be interesting discussion. And FMCW LiDAR with Doppler velocity can immediately understand that you are moving because you are experiencing some velocity and the pixels showing you the instantaneous movement. it's also proved by some papers, and some people are working on it, that localization and mapping with FMCW LiDAR could be faster and more effective in a specific degenerated environment. So robustness in adverse conditions. Due to the coherent continuous measurements, we can enable much better penetration through the fog, rain, and dust. And then immunity to interference and blooming. So this is in the combination with adverse weather conditions. Due to the coherent detection, we can be insensitive to the other LiDARs, which are also nearby and operating. And I was expecting that in the future, when we will have much more robots around, they will create so much polluted environment by the optical light that interference immunity will be very important at this time moment. And before I started with the points that LiDAR is actually expensive, bulky, and complicated device. But what we can do and what we are doing in our mission here is through the photonic integration to enable the compactness of this LiDAR with the co-packaging of lasers, detectors, modulators, no fibers anymore, very dense packaging together with electronics. Solid-state beam steering is another pillar that can enable and rule out some mechanical steering devices. Then system scalability and the parallelization, this is another pillar which is enabled by the photonics integration, because you will enable the high volume manufacturing and with the Siemens compatible processes, and you can also design as much as you need optical channels and make this system much more scalable and effective. And final point, through this photonics integration, we can significantly drop down the cost and enable the power effective solutions. So on the right side, you can see the picture of our first generation photonics integrated circuit with the 250 parallel steering lines, which enables 200 meters measurement range. So just a couple of words about the photonics enabler. Lasers, amplifiers, detectors could be co-packaged together with electronics and the electronic ICs to enable very small and smart device that could be placed in very small and limited environment. Because this is an optics purely co-packaged, it also could be silent in the different applications like harsh environment applications with a high pressure or vibrations. And photonics integration is a key step towards the low power consumption and the reduction of the cost. So just a video to show the contribution on the velocity. You can see here the video where the channel colored by the red and blue is the velocity, instantaneous velocity per pixel. There is no extra processing to detect the moving objects. This is a purely raw data coming out of the FMCW LiDAR. And to be more precise, I have another picture. When you can see the camera on the left, you can imagine that there is objects, and you can train your AI. You can understand that this is a people, there is cars, and so on. But you hardly can imagine where they will go. And you need to have much more frames, 2, 3, 5 frames more to understand the acceleration, to understand the direction and predict where they go. In the middle, you can see the range, which is a normal picture, which you can get out of the time of flight LiDAR, and you can understand the depth of the scene. You can precisely pick up the objects. And on the right side, this is the velocity of the velocity channel with instantaneous positioning of the objects which are moving in the scene. And you can see precisely the bicycle with the rider, the person which is moving in front of the car on the back side scene, And by the colors and the processing of the colors, you can understand the direction of the movement and predict ahead where is your next step. So I think it's all from the presentation of the FMCW technology and what we can do. Feel free to contact me next week at the Laser World of Photonics. I will be there. If you want to arrange the meeting, please call me at any time.
Thank you, Stanislav. But will someone be also at the Automatica for your to also present and position your solutions for the robotics applications?
Yes. Probably yes. Yeah. Sure.
That's excellent. I have a question because you've mentioned about that it's compact, that it's all co-packaged. The only thing, however, you don't go and give us exact numbers. So what are the relative the dimensions and the weight? Because if you want to place the system on the flying drone, the weight becomes critical.
Yes. So the weight is a very, very tricky question because we need to understand the use case. Yes. So if you'll speak about the application, the pipe detection and inspection, the weight and the size could be very small because we are not limited in the long range. The long range is always utilized in the big lenses and requires big lenses to deliver the light to the object. And this is a common problem for anyone, also for the cameras, if you want to have a high resolution. But we always need to speak about the root cause components. So the peak itself is a few millimeters footprint size. The electronics which is needed here is ASIC-based electronics, which is also in a few millimeter dimensions. And basically, it's all could be packaged in very tiny and smart package to be flying on the lightweight drones or to be mounted on some stationary objects to measure very long and ultra long ranges of a few tens of kilometers.
Jeroen, then the question may be from you, to challenge Stanislav. If you can have, let's say, a rough estimation, how big and how heavy the system, what's the maximum acceptable weight for some of the applications?
It depends. That's the usual answer, of course. So, yeah, indeed, like you already discussed, basically for a larger UGV, it's way less of a problem than a drone that has to be flying and has to stay in the air for as long as possible. Then, and we even developed some indoor drones in the past, actually, as well. So then it would only be a couple 100 grams. But for an larger outdoor drone, it could be about 1 kilogram, for instance. But it really depends on your application and your end pool as well. Yeah. So it's difficult to give exact numbers right now. That's basically the main thing.
Jeroen, this is being so interesting to have you in the room. We are going to continue with you because you need to keep evaluating these technologies. One thing, Stanislav, that we talk constantly is about frame rates. Whenever we are going to robotics, frame rates of the cameras become one of the special needs. This is a different market segment than the automotive. Before I give the floor to Jeroen, because he's going to have comments on this, I read your white paper, the white paper in the website, and it is estimated that your current frame rate is about 10 hertz, correct?
Yep.
Stanislav, thanks. Stay with us, Jeroen. Could you comment,
Sure.
what is the current demands, whether this is a LiDAR or a camera, but what are the current demands whenever you have to do very fast detection, positioning, or environmental check in a robot?
Yeah, just to provide a little bit of context. It depends on some parameters, such as how fast are you driving. I think here the unmanned ground vehicles are quite interesting. Like in the beginning, if you have a system that goes like at a walking pace, indeed 10 hertz. How fast you're driving determines how far you should be looking and how quick your response time should be. And then you should look at all the individual components and simply make a time budget for that. That's a typical system engineering approach. So it would be like your software needs computational time, your sensor needs time for registration, and then how much time you have is determined by the speed that you're driving at. So of course, like I think if you're looking at custom off-the-shelf LiDARs, current sensor that you could immediately buy with a range of like 40 to 50 meters, they typically have frame rates of up to 10 hertz. That's, I would say, that's still fine when you're still in the walking up to like 10 kilometers per hour, maybe even be possible. But if as soon as you be driving faster, then this may indeed become a problem. And yes, again, exact numbers are more difficult, but the frame rate goes up if you want to drive faster. That's the main message, of course. And you would have to look further ahead. And yeah, that's where especially these sensors with the long range become really interesting.
Stanislav, would you like to comment? Is there any way to
yeah.
increase the frame rate?
So I would agree that high frame rate is always beneficial. For the short range, which is below 100 meters, like in the range of 50, 100 meters, the frame rate could be ramped up to 20 and 30 hertz. So which should be definitely much better. And this is also connected to, because you are very close to the surroundings and you need to react fast. Usually what we know from our customers, ultra long range applications doesn't require high frame rate, and you have time a few seconds before you will make a decision. So even if you will move in very fast, but this is all systematically connected to the speed of the movements, the maximum expected speed, and the range. So I fully agree. So, but technologically wise, shorter range applications much easier to make high frame rate. It's not a hard stop on 10 hertz or 15 hertz. We can go for the 30 and 40 hertz for the short range applications, and especially with a very, very short range, we can go even faster. But then the frame rate is connected actually to the power dissipation and the power consumption. So this is actually the trade-off that we need to enable on the system engineering level.
Stanislav, Jeroen, stay because there is somebody I want you to meet. I'm going to introduce to the room a person who has been for more than 20 years working in the field of material and working in the field of optics. His name is Aidan Durak. He is now one of the consultants at Pygood Technical. Aidan, welcome to the meeting. Could you tell us what's on your mind? You had a really interesting comment in the chat.
Yeah, the question was for Stanislav. You mentioned a very wide range of capabilities on distance measurements from millimeters to kilometers. Is there a substantial difference in the hardware required, or is that more about configuration of the software?
It's configuration of the photonics components. I would not say it's a drastic change in the configuration of the hardware, because it's basically it's a scale factor, because as I said, we operate in a frequency time domain. So it means our laser tuning performance could be changed, and the scale factor could be also changed. So this is a big difference between the time of flight and FMCW, that we can scale down the range to the millimeters or scale up to the kilometers. System. And this is range in performance is software, first of all, plus a little change in the configuration. And sometimes if you want to get the maximum performance for the cheapest solution, we need to make hardware change and optimize hardware change. So of course it's trade-off. Yeah.
But if you were operating in a middle range, so you're not really at the maximum distance or the minimum, you can just do that by changing configurations without a big investment in different systems.
Yes.
Okay, very interesting. Yes. Thank you.
There's a lot of very interesting things that you want to hear today. So I then stay with us, because you're going to hear later on about the beamforming of a SteerLight, about the Flatlight technology. Please stay with us. But Jeroen, before I give the floor to really, really cool industries that can help with for the imaging side, I want to stay in the field of what is needed for companies like Demcon. And one of the big things that we keep asking in robotics is nano positioning and very accurate motion. There is two companies that I want to introduce to you, and I would like to have a discussion between all of us about what are the real needs in robotics. So first of all, allow me to bring to the floor Optica corporate member Smart Act, represented by our friend Frederick. Frederick, welcome to the robotics world. Please tell us a bit about the Smart Act, and also especially tell us a bit how could you address the robotics market and help Demcon with their job.
Yeah, so I will very quickly show a few slides about Smaragd. So we're actually a group of companies, Smaragd Metrology, Smaragd Automation, but I will stick to the Smaragd Motion today. So we are the company in the group that's specializing in high precision and compact positioning solutions. And in order to do that, we have now I'm allowed to start my video. Hello. In order to do that, we have 4 technologies that we use. So we divided ourselves into product departments, we call it. First, we have the SmartLight, which maybe most people know us for. That's the stick slip piezo drives, which we started 20 years ago. It's actually our 20-year anniversary this year for Smaragd. So there we have linear positioning stages, Z stages, rotation stages, goniometers, optomechanics, everything very compact, very precise, also able to use in harsh environments like ultra high vacuum, cryogenic environments, so for very special applications. Then we have the Smart Shift, where we use electromagnetic drives. They are better suited for high duty cycles, for faster velocities, not quite as compact as the piezo ones, but yeah, if you especially going into industry, high duty cycle robotics, then that's the technology to use. Third, we have the Smart Flex, where we use, again, piezo based, but it's a mechanical flexure. So you have movement around 200 microns or up to 200 microns with a very high repeatability. Also very high resolution and almost no mechanical play. And the fourth product domain, which I want to focus on today, is our Smartbotic. They basically, it's not their own technology, but it's our own kind of robotic department. They use the technology of all the 3 other departments and build more complex systems out of that. So for example, we have our hexapod-like systems. On the one hand, the SmartPod, where we have one of the most compact 6D hexapod-like systems with high resolution on the market. Here, the SmartPod 7042. It's 70 millimeters by diameter and 42 millimeters in height. So it's very compact, very high precision. And then another hexapod-like system is our tripod. That's more modular. So while the SmartPod is just a parallel kinematics, with the tripod we combine parallel and serial kinematics, allowing, for example, for a 6D system where you have unlimited rotation around the Z-axis, which is kind of special that you don't have that with a normal hexapod, right? And another topic important for robotics is, of course, the micro grippers, also part of our Smartbotic team, where we have different micro grippers. We can do customized jaws for different kind of applications in the photonic markets. And we also have, like here, the SGP gripper, which can have integrated force sensors. So if it's important to measure your gripping force, that's also something that we can do. So I would like to end with some application example of the semicon and photonic market. So this is our microassembly gantry system, where we combined basically all of the technologies that we have. So you see the long axis, that's one of our electromagnetic direct drives used as a gantry here. The sorting tray is the smaller EM drives. Then we have a tripod for aligning an optical fiber, and we have our grippers that grip a small beam splitter cube. And on my next slide, I would have a video demonstration of that setup. But I think I would rather invite you all to visit us at the Laser World of Photonics next week, where we bring this demonstrator and also many other demonstrators with applications of the photonics market. So please drop by.
Frederick, I will
and
come with the camera and the microphone. I'm going to film it live for everyone. Frederick, allow me to also bring to the stage another company who has a certain overlap, but I want Jeroen to hear from them before he leaves. Justin Bressy, thank you very much for being with us from, sorry, I made a mistake. Justin, thank you very much for bringing Aerotech today to the room. Could you tell us a bit what you do in the field of robotics?
Yeah, so as you mentioned, there's definitely a little bit of overlap, but Aerotech is a precision motion control company. We make stages, drive electronics, and a software controller for nanometer level, micron level positioning applications. So I actually have a slide or two I could share if you don't mind, Jose. Is that all right?
If it's one, it's better than two.
One, okay, yeah, I'll show one. So let me just pull this up really quickly, just to kind of summarize what we do here at Aerotech. So really, we offer a varying range of value that we bring to our customers, starting at the bottom of this pyramid here with our pre-engineered components, which again, we make stages, rotary and linear stages with servo motors, and we also just make the motors themselves, as well as hexapod platforms and laser scan head technology. So Galvos, 2D, 3D, and 5D laser scan heads, as well as the drive electronics to control those products, and the software controller, our Automation One controller, which controls our whole suite of motion products, including our laser scan heads, which gives us the ability to synchronize those scan heads with the servo stages. And then one layer above that is our custom engineered motion subsystems, which makes up a lot of our business, where we take these building blocks of our pre-engineered components and integrate them with some customization, sometimes very high levels of customization, to address specific needs of specific applications, whether it be in the semiconductor industry, photonics industry. We also do a lot of work in laser systems and medical and other areas as well. So custom engineered motion subsystems is really where we bring a lot of engineering expertise and kind of prescribe a specific solution to a challenge from our customer. And then finally here, our integrated automation systems, where we build full turnkey machines for certain market verticals. And basically, we will work in collaboration with our customer to understand the whole process that they're trying to solve. We'll build the motion engine and then collaborate on the process elements of that process. And then we would build the full up machine almost in a contract manufacturing arrangement. So this is kind of who we are as a company. Again, varying levels of value that we bring to the table, starting with our motion control products, but then elevating up through higher levels of customization and engineering for bespoke equipment.
Yes, Jeroen, Justin, thank you so much. Frederick, Jeroen, could you challenge these two companies? What are the current challenges when it comes to precision motion that a company like Demcon has?
Well, one of them would be like a company as Demcon is always operating for a different kind of challenge. We are project based, so in that sense, and what I really liked also in the talks of both of Aerotech as well as SmartAct is that they emphasize the modularity a lot as well, and the flexibility to adjust the system against specific requirements. That's really something that is important, but I also see it well addressed on the other hand. So that would definitely be one thing. And on the other hand, of course, the hard requirements of accuracy and precision levels, of course, are always definitely a challenge. In combination, with small spatial budgets, things have to be small usually, and then still precise, and those kind of combinations. Yeah, we really focus on integrating those systems and really defining proper interfaces, and that's definitely one of the challenges that we currently see.
Jeroen, after this meeting, you understand you're going to get a lot of email introductions and requests. If anybody wants to be introduced to Demcon, send us an email. Allow me to switch gears now. This is a very exciting part of the meeting for me. This is one of the biggest developments in optics and photonics in the last years. We have seen a huge amount of developments when it comes to beam forming, beam steering, and wavefront shaping. Really one of the most exciting fields in the world. And today we are bringing to you two of the newcomers two of the companies that are getting most excitement in the investors ecosystems. And you're going to be really excited about what is showing, what is going to be showed in the next 10, 20, 30 minutes. Allow me to first go to a company called Flatlight and the world of active metasurfaces. Renato, thank you very much for joining the meeting today. Show us what you can do, who else can help you, and what kind of innovation made me so excited.
So yes, thank you very much, Jose, for this invitation. Also, Olga and all the Optica Corporation always helping me. And so yeah, first I would like to introduce myself. I'm Renato. I'm the CEO of Flatlight. It's a French startup based on south of France that we have been incorporated last year. So a pretty young startup that's going its way through the market. So the problem that we're tackling within Flatlight is the problem actually of the light control and light engineering overall of the systems that are not very efficient nowadays. You can see, for instance, that mechanical scanners, for instance, they are bulky, they are slow, they occupy a lot of space, they are not integrated. Therefore, we also don't see a very high level ADAS in the system with mechanical scanners, which means that there's some lacking of performance there. Photonic integrated circuits, they are the good solutions as Cantino presented, but there's still a very loss photonics systems. That's why actually using FMCW is one of the solutions to overcome of these loss devices. Moreover, another a component that is using a lot to explore this light control system is a system that's called LCOS that has been in the industry for several years, but those are not performant enough. So what we introduced in the Flatlight is a new optical system that we call the NanoSLM. So what we're using here is what we call the active metasurfaces, which are composed of nanometric pixels that are smaller than the wavelength of the light, its pixels. And by playing with the phase of the light by these very small pixels, we can actually control the light. Not only control, but you can also achieve a ultra high field of view for around 80 degrees, ultra fast scanning that's around 100 times faster than what people can do with LCOS systems. It's highly reliable system because you don't have any light absorption, so a single packaging in the system can control all the thermal properties. It's a very compact system that can incorporate millions of pixels in a very small area. It's a high efficient system that can deflect around between 80% up to 95% and also high integrability, which means that you can integrate this kind of system in your LiDAR system and also in other solutions. So how does it compare with the other system that exists nowadays in the market? For instance, if we take that sample of the PIC, the LCOS, mechanical scanners, basically our technology can outbid all of these components. We can perform ultra-high scanning speed, ultra-high field of view. That's 100 times faster than LCOS device. It has 8 times higher field of view, the photonic integrated circuits. It's 10,000 times faster than mechanical scanners, twice more efficient than a photonic integrated circuit, everything in a cheap level that provides the high integrability. So the applications that we're looking into Flatlight, there are several verticals that we're exploring. For instance, in the field of surveillance, where we need fast scanning and also ultra high field of view, we can integrate there. We can also perform metrology of the system by projecting a light holography system that can use for chip inspections and advanced manufacturing. You can provide a structured illumination with the active metasurface for calibration system as well, and also optical communications. A very interesting new vertical that we're exploring within Flatlight is now the optical computing using active metasurface, where we can perform actual vector matrix multiplications, which is a very well-known applications of metasurface, and also we're exploring the directions. Currently in Flatlight, we're looking for partners to test our technology, to build pilot projects, to explore applications. And if you're interested in what we're developing, please reach out with me and we can discuss better. Thank you.
Thank you, Renato. Tell us a little bit more about the partners that you're searching for. Is it someone for packaging? Is there someone for design?
Exactly. Thank you, Olga. Yes, what we're looking for is actually partners for packaging, and partners also for integrated the outside part of the metasurface. We're just developing the core part of the circuit, which is the active metasurface part. And what we're looking for is user case people that can help us developing the full product, either in a LiDAR system or also like going for other verticals that we're exploring.
Thank you very much. Jose?
I would like to know from a company like Flatlight, how do you interact with the robotics industry? What is the first reaction that you have gotten from a company like this?
So in the robotics field, what we can explore actually is the autonomous robots. That's one of the first application. People that are building robots that want to integrate a fast scan system within the LiDAR. Not only that, also in the manufacturing side, what we're looking for also applications in the metrology. As explained, we can project some light field structured light, and by using this light field, actually we can play with the role of using a ultra-fast metrology system that it's ultra precise.
The world of meta surfaces, meta optics, meta materials is getting a lot of interest these days. And I was actually in Boston a couple of weeks ago. I met with Professor Capasso and tried to understand what is the future. What is the future of this industry? And the feeling is that while in the beginning, originally, deep UV lithography could solve all the challenges, there seems to be that there are new challenges that deep UV cannot solve. What is your vision on this?
It's a very interesting question, actually. I can see active metasurface playing a role in several fields. In the terms of deep UV lithography, you're asking, or it could be used as a new system, but actually there's a big challenge there in the deep UV in metasurface because since the structures must be smaller than the wavelength of the light, so if we're playing for deep UV, we're talking here about very, very small nanocomponents. So far, the applications that we're exploring here are within the visible applications and up to infrared, which means that we can create structures that down to 300 to 500 nanometers. I think the main challenge here is actually to come up with active system that can be small enough in terms of these nano antennas, because those are the building blocks of the metasurface. At the same time that we can play with the high aspect ratio, because these components in terms of fabrication, that comes with the challenge of the propagation phase. In order for the phase to propagate within the metasurface, you need a high aspect ratio. So if you bring that structure down, let's say to 10 nanometers, talking about very deep UV here, then I think there's a big challenge in terms of fabrication, and but I don't see the physical limitation there. I think that's it's just a matter of the market being involved enough to reach that point.
How would you evaluate the state of the technology for 1550? Stanislav works in 1550.
50-50 is actually very feasible in terms of wavelength range. Actually, you can operate all the range from visible to the near infrared. So as I mentioned, the structures, they should be smaller than the wavelength of the light. So if we're going down to the infrared, it's get much easier for us to fabricate the devices. So 1550 is actually, it's the easiest, let's say, path for us to fabricate.
Thank you so much. Yes. Go ahead.
So you picked up a very interesting point here that the limited field of view could be the problem. But I would say it's not a problem of the photonic integrated circuits. It's a problem of the classical optics in general, in total. So the classic optics is always limited in the field of view, and this is always the problem that metasurfaces like you are presenting can solve. Just a question, what is a expected aperture size you have, and do you have samples?
We are currently working on the first 1D array of active metasurface in terms of demonstrators, so we cannot provide yet some demonstrators. So in terms of aperture size, what we are predicting for the initial demonstrator is something around 1 millimeter as aperture size, but we can go up to 1 centimeters by playing with some grouping of pixels and so on. Depends on the architecture that we are talking about here. But I mean, the aperture actually plays a role in the, I guess for you it's very important, right? Because you need the precision. So for you, it cannot be too small. Otherwise you have the diffraction of the light. So you cannot keep it up with the precision. So yes, I mean, we can go up to around 1 centimeters and down. I mean, down, we can always go down. It's metasurface, so it's nanometric.
Okay,
The problem is to go up. Yeah.
Thank you so much, Renato. And then I will use this opportunity to introduce the last speaker of today, François Simoens from SteerLight. François, please join us and tell us how SteerLight can address and help the field of robotics.
Yes, thank you for introduction. Have you got my slides, or do you want me to share it?
Please share.
Okay,
Yes.
so yeah, so thank you, thanks. Jose, as you said, yes, I'm very pleased to introduce SteerLight. We are also quite a new company, a new startup based in France, in Grenoble, French Alps. And I co-founded with Jeroen in 2022. And what we develop is an optical engine for LiDARs, for beam steering, FMCW. We target a progressive access to markets. And the first one is robotics, before serving the automotive market, as illustrated by the fact that we have Stellantis on board of our company. So what we develop, we want to develop modules that would be able to unlock the full potential of LiDARs, and in particularly relative to this presentation today, we want to develop a module that will enable safety 3D vision sensors for robotics applications. And more at the beginning with safety scanners, or it's not even said as being a LiDAR, it's called a security organ, mainly for logistic industry, smart infrastructures. So what we want to combine is to be able to have something very compact, very modular, but not without sacrificing the performance. And our vision is then to see if you want to have this, instead of having very cumbersome LiDARs modules covering a large field of view that are sometimes not useful for example, integration in autonomous mobile robots as presented here, you can combine different modules. Each one is covering typically 90 degrees of field of view on a planar direction for this first product. And if you want to cover 270 degrees, you combine one master and two slaves. Or if you want, for example, only 90 degrees, you have one at the rear of your robot. So it's very practical approach to just serve what is needed for the application. And to do that, we use a unique approach for the beam steering. We are a spin-off from CLT in Grenoble, and we've been working on optical phase arrays integrated in silicon photonics chips for more than 10 years. And from that, we have now the ability to design, optimize this device, control and calibrate on chip all the different elements of the system. And with that, we can achieve a beam steering with no lens, no moving parts, and only an electronic control of the beam steering direction. Typically, for the first product, that is a safety scanner, that means that it will be certified as SIL 2. I don't know if you're familiar with that. It means safety integration level 2. We will target to have what is needed by the regulations. It means typically 5 to 10 meters of range, but very small one. No mechanical alignment in the process of assembly because we have no lens and it's only with the standard semiconductor assembly techniques. And with a very small size, typically we target to have something at the size of a visit card with a height of typically 3 centimeters, because of course you need also to add the imaging processing and how to deliver the point cloud to the customer. And what is specific to our solutions in addition to have very flat integration, is that with the OPA, you can have a very flexible beam steering on the flight, and we have already tested and demonstrated. You can go fast, you can go longer time, you can change the beam steering pattern just on a region of interest in combination to other possible sensors that your robotics applications have. And so it's very, very powerful for many applications for this applications. And what we do is now we are launching the production of a first prototype with this integration. And in the meantime, we do test with prospects with this kind of applications to have the evaluations of the added value of our solution. So we are interested to meet any robotic players to know what are their needs and how our solutions can fulfill their expectations. And then in the second time, we will extend the range and extend also the field of view, horizontal and vertical, for other applications in mobility. And just one word for the field of view.
No, please continue. Go ahead.
No. Oh, I just finished. Just one word about the precedent presentation. The field of view is absolutely not limited. We can cover 90 degrees easily with no change in the power that is emitted. Why we limit our field of view to 90 degrees is that because you have, when you go further, you have a decrease of the power for angles that are higher. But for some applications, it appears when we talk to customers that actually it can be an asset for some use cases that we are talking with them. So now, okay, so that's it. I think I would be very delighted to talk to you, and don't hesitate to contact me for collaborations and for test of your use cases.
Thank you so much, François. You seem to, it's a very advanced and also challenging technology and challenging modules. So what are your challenges as a developer? Is it packaging or availability of the specific deposition methods or really surface processing methods?
So for the technical aspects, I think we have gone through, for this gen of product, gone through all the bottlenecks. We are fabless and we have identified the supply chain. I would say that the most demanding aspect we're working on is the cost to design aspect. We want to serve many applications, and LiDARs, we want really to break the glass ceiling of the price that is really hindering the deployment of radars. So we want to have something fully compatible with the standard semiconductor players, either for silicon photonics chips, ASICs, but also for assembly. So no optical alignment, it's done by itself in these companies. And but the main things are really the packaging. I would say the packaging of the laser with the chip and so on. So we want to get rid of anything that is adding value, adding cost to our solutions. And this is, I would say, one of our major achievements in the last several months is that we have now a very, very efficient coupling between the laser and the chip, and very low cost.
And
Give
so
it a
we're
number.
all in. Oh.
What is a very high efficient coupling?
So I cannot say exactly. It's quite secret for now. Actually, our customers don't care about the way we do it. What they want to do is the cost. So this is, I would say, that's really the main challenge for us, is to go to the market and to try to find something where we kill all the cost features. And there are many ones, the thermal coolers that you may need, the micro optics you may need, and all these things. The packaging also is very, very important to take into account. And so this is really the main challenge we have on this gen of product that we're working on for now. For
François, we are very impressed. Very impressed with what you're doing. Before I give the floor to Stanislav, Olga, François, very impressed with what you're doing in the field of bringing silicon photonics and phase antenna arrays. Is fascinating. We have discussed a lot about LiDAR in a meeting like this one. I wasn't expecting that, Olga. I thought it was going to be more in the robotics. LiDAR is here to stay, and I wanted to bring to the floor one corporate member of Optica who has made an impact on testing LiDAR. Mirvais Yousefi, CEO of Scramblux. Welcome to the Optica Summit on Robotics Online, which has a special issue on LiDAR today. Could you tell us a bit of what Scramblux does?
Yeah, thank you very much, Jose. This is very kind of you. First of all, it's the CTO. So I'm responsible for technology and I spend money. I don't bring in money. That's the most important one. We are a LiDAR testing company. And so we are essentially taking over after François has assembled this system to validate that it performs according to the specs that he's delivering to the customer. We have built a new portable, it is not a small footprint system. Today in the industry, when you want to test a LiDAR, you need tunnels. You have 30-meter tunnel where you have a target at a certain area and you look for the probability of detection. We do this on a 2x2 meter footprint. And we can take any wavelength, well, within reason. I mean, we go from, let's say, visible up to about 2 microns. After that, I'm not sure anybody's going to make a LiDAR for that. So we do that, and we can do any ranges between 0 meter and 30 meter for the immediate, but we can also use optical lenses to improve the range. Most importantly for us, it's not a detection and emission system. The photon you emit is the photon you get back. There is nothing in there that is going to block. There is no dispersion in our systems. So if you're doing FMCW, you get back your frequency profile, whatever you're getting back. If you're doing time of flight, you get the exact intensity coming back, etc. And especially, I know that for robotics, one thing is the longest range, but the robotics accuracy is key. You need to know where the thing is, and you need to know that to a few, hopefully a millimeter, but centimeters accuracy. We can give you accuracy performance. We can test your LiDAR relative to accuracy down to 3 millimeter accuracy on our instrument. So our instrument is 3 millimeter. With this, you can measure how accurate your system is. Yeah? I think I'm going to just take that much of your time because I'm not really on the program. Questions, please.
I'm going to take some of the time of Stanislav.
Right.
Scantinel develops FMCW LiDAR, and I would like you to comment how you would use this as a way for testing your LiDAR.
Thank you, because I do know their LiDARs, of course. I can tell you one thing that we can do that nobody else can do at the moment, even the tunnels. We can do moving targets. So we can get you the Doppler shift off your target up to 100 kilometers an hour. That is the number we take from the automotive industry. We are mostly focused in the automotive. So unlike everybody else, we can actually give you moving target. I have advertised it many times to Stanislav himself.
Yep.
And so I'm hoping after this meeting, we will have a few Scantinel LiDARs to play around with. Yeah?
Yes, I pay for the shipping expenses for Scantinel LiDAR to Scramblux. Stanislav, tell us what's in your mind.
Thank you very much.
Thank you. So basically, of course, we are testing in the tunnel. So 300 meters tunnel, it's not super expensive, but it still takes time. And if you want to walk through this 300 meters back and forth, you're spending a lot of time. So definitely the proposal from the Scramblux is brilliant to short the time and to make it parallel testing. And so this is a very good proposal. Unfortunately, we are not here in this moment with the Scramblux, but I hope we had some discussion with our testing team, but I don't know the results. So, but what you said, moving targets, I think it's very crucial, because how to calibrate moving targets, how to precisely identify that this is a moving target, it's very hard to simulate in the real life. And the range accuracy and precision, it's also very hard to simulate. So I definitely believe that this solution is very important for LiDARs. And if you're speaking about the robotics applications, we need to have a precision and the precise calibration. That would be very, very helpful here, I think.
Mirvais, stay with us because the CTO of Scramblux, Simon, if you're watching this, I didn't mean to take your job away from you. Mirvais, CTO of Scramblux, François Simoens just presented his way of doing beam steering for SteerLight, and he's working with many LiDAR companies in the field of automotive. François, is there any particular challenge that you would have when it comes to your wavefront way of understanding LiDAR for testing?
What is interesting in what has been presented is to have, I would say, standards for calibrating, for example, the velocity in the power cloud and so on. For now, we have also tested with our customers moving targets. It's very important. Calibrated moving targets also, as you know, we have to obey some regulations in terms of reflectivity for the target. So we have acquired, we have bought very expensive, I would say, calibrated targets to validate that we are fulfilling what is expected in the regulations for safety scanner. But of course, as I said also by Scantina, it's very important for us to have access to long range and so on. So equipment where we will be able to test our prototypes before going to the customers.
François, the offer is on the table also for Stanislav. If there is any LiDAR system that you would like to test, I pay for the shipping expenses, so it goes to Scramblux. Mirvais, one more company. I want to go to Besi, one of the key companies in contract manufacturing, supporting many customers on building LiDAR systems. Hannes Wickler, it's been a while. Hannes, tell us what's on your mind. How do you support your companies, your customers building LiDAR?
Thanks, Jose. We are not contract manufacturer, but machine equipment supplier.
Builder, sorry.
And this was a great meeting today because we had, for me, I had both. I had on the one hand side potential suppliers because we are at the end users of all the control systems, of all the end effectors, stuff like that. And we integrate that in our equipment, in our machines, to then help our customers building photonic system, packaging them, the same for LiDAR. So yeah, for me, it was end to end. It was a great meeting. Thank you for that one.
I think it was a great meeting as well. I believe that all of us have found potential partners, suppliers, and customers in the room, all of us, including me. So please make sure that all of you receive an email after this with the slides, with the thank you. Reply that email telling us with whom you would like to be introduced, and we'll be more than happy to make this introduction. Ultimately, this is the reason we spent exactly 1.5 hours together. We started on time and we finished on time. I would like to thank all of you, but especially the company Demcon